Investigate the graph of y equals x squared plus a constant by hand, table, with technology, and then generalize. You will need graph paper or a page of grids, and this is part of the Family of Functions series. Let's first graph y equals x squared using the parabola dance as we did in previous videos. So we'll start with the vertex, and then we'll go right 1 up 1 squared, right 2 up 2 squared, right 3 up 3 squared. And then we could either use the idea about being symmetric about the y-axis to get 3 other points, or we could left 1 up 1, left 2 up 4, and left 3 up 9. Again, remember to pause as needed. We'll connect the points, and we get the beautiful parabola. So keeping an eye on that parent function y equals x squared, let's graph y equals x squared minus 3. So we're going to have you make a table with 5 rows as shown below. So please press pause and fill in the table. All right, so continuing, putting in 2 squared is 4, minus 3 is 1. 1 squared minus 3 is negative 2. 0 squared minus 3 is negative 3. Negative 1, the quantity squared, is 1, minus 3 is negative 2 again, and then we go back to 1. So plot those points. Again, press pause as needed. And we plotted all 5 at one time. We'll connect the points, and again, another beautiful parabola. So what we'd like you to do is talk about how the graphs are similar and how they're different. So press pause and make note of those, how they're similar and how they're different. You can see that they're really the same ordered pairs, just in a different spot. They're the same points, okay, in different spot. One is up higher than the other. So they're similar, yet they are different. And looking at the graph, you can see the vertices are down 3 from where they normally are on the y equals x squared. This point, these 2 points correspond, and it's down 3 from the blue one. This one is down 3 from the blue one, and so on. I'd also like you to place a table of y equals x squared next to that one. So press pause and continue when ready. So this is our y equals x squared table. And I'd like you to look at the y values for corresponding values of x. So for example, when x is 2, look at the y values. When x is 1, and there seems to be a pattern here. And finally, when x is negative 2. So how far apart are the corresponding y values? In each case, the green one is 3 less than the blue y coordinate. They're 3 apart, or you could say they're 3 below what they were before. So that down 3 that we saw graphically, that 3 below that we saw in the table, and there's definitely a relationship there, and it's all to that minus 3 right there in the equation. We say that the graph of y equals x squared minus 3 has a vertical shift down 3 from its parent function y equals x squared. So we're going to use that phrase, vertical shift, shift down 3. You can see it in the graph, and you can definitely see it in the table. So we're going to repeat the same exercise, but with a different equation. So keeping an eye on the parent function, let's graph y equals x squared plus 2 by first making a table. So please make a table, pause as needed, make the table. So completing the table, again, 2 squared is 4 plus 2 is 6, 1 plus 2 is 3, 0 plus 2, 1 plus 2, and 4 plus 2. And as we did before, we're going to plot those 5 points all at one time and connect the points and get another beautiful parabola. And the graphs are similar, yet different. They're the same curve, just one is shifted up higher than the other. And so when we take corresponding vertices, you can see that the green one is up 2 from what it normally is. And when we compare other points, they are up 2 in all cases. We also looked at the table of y equals x squared next to it. So let's go ahead and put that table in. And let's go ahead and look at the y values for the corresponding x values. And as you can see, there's definitely a pattern there. How far apart are they? Well, they're 2 apart. They're up 2 from where they were before. You can see that in the graph. You can see it in the table. You can see it in the equation. So again, we say that the graph of y equals x squared plus 2 has a vertical shift up 2 from its parent function y equals x squared. That's the terminology we'll be using. You can see it in the graph and in the table. So if you have TI-Nspire technology, whether it be a calculator handheld, software, or an iPad app, we strongly encourage you to play with the technology and discover some patterns when graphing. So we're going to investigate the graph of y equals x squared plus some constant using technology. If you do have TI-Nspire technology, please use the TNS file, the TI-Nspire file called x squared plus v. All right, so let's look at this so we can make sure you understand what's going on here. The graph of y equals x squared is in blue. It's dashed blue. Y equals x squared plus whatever the constant in, right now 0, is in green. We have a table over here for values -4 to 4. And this is the blue x squared, and this is the x squared, in this case, plus 0. And this is called a slider. And pressing the up arrow increases the slider value, and down arrow decreases it. So right now you can see these are identical ordered pairs. So let's go ahead and increase v to 1. And you can see that the function changes, the graph changes, and so did the table. And look at the values here in the blue and the green. Y equals x squared plus 2. Look at the graph. Look at the table. X squared plus 3 compared to x squared, 4, and so on. 6. All right, again, look. So now I'm going to go back down to x squared plus 0. And let's look at x squared minus 1, or x squared plus a -1. Look at the graph, look at the table. X squared plus -2, which is x squared minus 2. X squared minus 3, and so on. Pause is needed. So let's go ahead and summarize what we discovered. So I have some screenshots here of these of the functions. Parent function in blue, transform function in green. So this is y equals x squared plus 0. So here's y equals x squared plus 1. You'll notice up 1, and notice the table, what's going on in the table. Y equals x squared plus 2, up 2 on the graph, and look what's going on in the table. Y equals, jumped up to x squared plus 5, up 5. Again, look at the values in the table. And then we looked at x squared plus a -1, down 1, and the values in the table. And y equals x squared minus 4 plus a -4, down 4, and in the table. So generalizing what we've learned, the graph of y equals x squared, the parent function, and the graph of y equals x squared plus some constant, we're using the letter v, are the same curve, the same set of points. If v is positive, the graph shifts vertically upwards from y equals x squared. And if v is negative, the graph shifts vertically downwards, the absolute value of that negative number of units, from y equals x squared. This concludes the video.